Specific heat of a sample can be measured by DSC from heat flow of a sample at a specific heating rate within a desired temperature range. Two methods can be used. First one ASTM method and the second one heat-cool method. First, we need to know the relationship between DSC heat flow and a specific heat. The heat flow in DSC at a specific temperature can be written as del Hs equal to Ms Cps times delta T temperature delta T time equal to Ms Cps Rs. Cps equal to del Hs divided by Ms Rs, where del Hs is the heat flow in watt, Ms is the mass of the sample in gram, Rs is the heating or cooling rate degree C per minute, Cps is the specific heat of a sample, joules per gram per degree C. From the second equation, we can calculate a specific heat of the sample. In most cases, DSC heat flow is given as watt per gram. In this case, Ms is not required to use in the above equation. It is not possible to measure absolute value of a specific heat of a sample only by running the sample with a blank reference pan, because baseline are dependent on the instrumental design. In this case, ASTM method uses a heat capacity calibration factor based on the heat capacity of a well characterized material, commonly sapphire. The correction factor is F equal to CPM divided by CPN, where F is the correction factor and CPM and CPN are the specific heat as measured experimentally and standard literature value. It is in joules per gram per degree C. We could use this correction factor to calculate the specific heat of a sample accurately. The following equation can be used: CPC equal to F CPM. In this experiment, we will use water as a reference material and dead fruit flesh as a sample. Consider we want to measure a specific heat of dead flesh from 10 degree to 80 degree C. First reference, that is water, was at room temperature as located at point 1, that is 20 degree C. It was then cooled to point 2, that is 10 degree C at 5 degree C per minute and held for equilibrium for 3 minutes. After equilibration, reference water was heated from 10 degree to 80 degree C at a heating rate of 5 degree C per minute. How to calculate a specific heat? We can use the equation as I have mentioned earlier. I am showing the calculation at 40 degree C. The heat flow at 40 degree C is 0.4007 watt per gram. Measure the specific heat of reference or standard as we can calculate. CPR equal to del HR divided by MRRR, which is equal to 0.4007 watt per gram divided by 5 degree C per minute, which is equal to 0.4007 joules per second per gram divided by 5 degree C per minute times minute by 60 seconds, which is equal to 4.8084 joules per gram per degree C. Specific heat of water at 40 degree C is 4.1786 joules per gram per degree C. Then correction factor is F equal to CPM divided by CPN, which is equal to 4.8084 divided by 4.1786, which is equal to 0.8690. This is the correction factor. For sample, we need to use same protocol as reference. Heat flow curve is given as shown. as we can see as 0.2508 watt per gram. Measured specific heat of sample, as we can calculate CPSM equal to del HS divided by MS RS, which is equal to 0.2508 watt per gram divided by 5 degrees C per minute, which is equal to 0.2508 joules per second per gram divided by 5 degrees C per minute times minute per 60 second, which equal to 3.0096 joules per gram per degree C. Specific heat of sample with correction factor is CPSA equal to F times CPSM, which is equal to 0.8690 times 3.0096 joules per gram per degree C, which is equal to 2.6154 joules per gram per degree C. Wade et al. 2023 observed the error range of ASTM as ±2% to ±5%. The major drawback of the ASTM method, it requires two separate experiments. The first measurement is with standard or reference of known mass for calibration. The second measurement is with the material of interest. This is costly in terms of time and can introduce additional uncertainties. Wade et al. 2023 explored an alternative heat-cool method for measuring specific heat in a single DSC experimental run. In this method, a measurement of heat flow is performed during heating and cooling cycle for same sample. Instead of using a standard or reference material, it measures the difference between the heat flow during heating and cooling cycles of the sample. The equation for a specific heat can be written as CPM equal to del HS heat minus del HS cool divided by RS heat minus RS cool times MS, which is equal to sigma by 2 RS, where sigma equal to heat flow watt per gram and RS is heating or cooling rate degree C per minute. In these heating and cooling periods, heating starts from point 1, that is 10 degrees C, and ends at 70 degrees C, that is point 2. Then sample cools from point 2 to point 3, that is 10 degrees C. For example, at 40 degrees C, heat flow during heating is del HS heat, and during cooling it is del HS cool. From these values, we can calculate the specific heat of the sample as shown in the earlier slide. Advantages of heat-cool method. Wade et al. 2023 method is more accurate and reproducible. Errors varied between ±1% and ±2% range. The proposed method is faster and typically requires no additional calibration beyond the routine calibration of temperature and heat flow of DSC. Overall important points. Possible sources of error could be due to the phase change in the sample. For example, pan leaking could result in the loss of water by evaporation of moist samples. In this case, achieving a hermetical sealing of the pan is required. Adequate equilibrium time needs to be used before and end of DSC run. It is recommended to use an equilibrium time 3 to 5 minutes. Heating rates of 5 to 10 degrees C per minute would be recommended. Thank you for watching this video until the end. Please share, like and comment if you like this video.